Hi, welcome to Math Time with Mrs. Depperschmidt. Today we'll continue working with multiples, only not just of a single number. We're going to compare some lists of multiples for more than one number. As we get into working with fractions and harder multiplication, learning how to find the common multiples of more than one number will be very important. The first method we'll try out is find common multiples by comparing lists. Step 1 in this process is to list some of the multiples of each number. As an example, we'll start out finding the common multiples of 4 and 7. As always, if you'd like to get paper and pencil, work on your own with these, that would be great, and I'd love to see the work you've done. We know that multiples mean counting by, so finding the multiples of 4 is going to require us to start out with multiplying 4, first by the number 1, which is 4, then by 2, which is 8, and I'll make a list of multiples with a comma in between. So the first two multiples of 4 are 4, 8, and I'm sure you already know next is 12, then 16, 20, and sometimes when we're doing it with the list method, we don't know how long a list we're going to need. So I'll keep going a little ways more since I have more paper and we're not sure how many multiples we'll need. Counting by 4 after 20, we get 24 is the 6th multiple of 4. The 7th multiple of 4 is 28. The 8th multiple of 4 is 32. The 9th multiple of 4 is 36. And the 10th multiple of 4 is 40. I'll use an ellipsis there to show that the numbers keep going and the multiples of 4 are not over, just that I'm done writing them down. Now let's write the multiples of 7. That means we're going to count by 7, starting with 7 itself. One group of 7 is 7. The second multiple of 7 is 14. The third multiple of 7 is 21. The fourth multiple of 7 is 28. The fifth multiple of 7 is 35. The sixth multiple of 7 is 42, and so on. Now we've got enough multiples in our list to see if there are any in common. Check both lists and see that's where we get the word common from. Is there a common number that is both a multiple of 4 and a multiple of 7? As you're thinking about that, I'll remind you that step 2 for finding the common multiples of two numbers is to circle any numbers that are common or the same in both lists. And you've probably already found out that in these two lists, numbers that are multiples both of 4 and 7, let's see, what is a multiple of 4 that is also a multiple of 7? I'm sure you found it. It's 28. And we've circled those in our list. And we would say that the one common multiple of 4 and 7 is the number 28. When you're counting by that number, that's a number you would land on with both 4 and with 7. If we were to go on and on and on, there would be more and more and more multiples of 7 and 4. But they get farther and farther apart, and they are higher and higher numbers and can get kind of cumbersome to work with. A lot of times we'll want to find the smallest number that is a common multiple. And you might see that written as least common multiple or lowest common multiple. The lower ones are necessary because they're much easier to work with. I'm going to show you another way to find common multiples when the list method doesn't work out. This is called the dividing method. And we're going to divide both numbers by something we know would work. Let's try. Let's see. What do you know is a factor or a number that we can divide evenly into both 18 and 60? Let's start with the smallest number we can, excluding 1, because we know that 1 is going to give us the other factor of the number itself. And I'm pretty sure there's a lower number, lower multiple for 18 and 60. Okay, I know that 18 and 60 are both divisible by 2. So I'm going to put 2 out here on the side of the L chart. And I see that 18 divided by 2 gives us a result of 9. I also know that 60 divided by 2 gives us a result of 30. We know that 60 is a multiple of 30 and 2. Also, we know that 18 is a multiple of 9 and 2. Now we need to move to the next numbers down here. What can 9 and 30 both be divided by evenly? We make another layer on our upside down cake. Or we could call it a floor in our building. You've probably discovered that 9 and 30 are both multiples of the number 3. So let's do that next. Okay, think, how many times does 3 go into 9 evenly? We know that's a 3. How many times does 3 go into 30 evenly? We know that's a 10. Okay, now we factored everything we can factor. 18 has come down to its smallest factor. We know that 18 is 3 times 3 times 2. We know that 60 is 10 times 3 times 3 times 2. Now let's find out what our common multiple is. We need to multiply all of our numbers on the outside of the cake to find out what the lowest number is that is a multiple both of 60 and 18. Let's figure this out. I'm going to save the 10 for last. I know that 3 groups of 3 is 9. 9 groups of 2 is 18. 18 multiplied by 10 is 180. I'll kind of think about it as a sort of a downstairs step multiplication problem to find the lowest common multiple. We started up here with 2, multiplied by 3, then multiplied by another 3, then multiplied by 10, gives us the result of 180. That's the lowest common multiple of both 18 and 60. Then to check our work, we know, let's see, 18 goes evenly into 180, so we know that counting by 18s, we would land on 180 after we say it, count to 10 multiples. And we also know that 60, if we count by 60s, we will exactly land on 180. 180 is the lowest common multiple of both 18 and 60. We'll work more with multiples in class. If you'd like to bring an example or a model of your work from this practice session, that would be lovely. I'll see you at school. Please be kind.